white light, like sunlight, is composed of all the colors that you see in the rainbow. If I scatter white light of very small particles, then the blue light is scattered more than the red light, and we give that a name in physics. We call that Rayleigh scattering. Rayleigh scattering only happens when the particles of which the white light scatters is smaller than 1/10 of a micron. That means 1,000 times smaller than the thickness of your hair. So it has to be very, very small. If the particles are as large as 1/2 a micron, then there is no longer Rayleigh scattering. There is no preferred scattering for the blue light. All colors scatter equally, and so white light scattered of particles that are 1/2 a micron or larger remains white. The dependence of the power of scattering, so I'll give that P, the power, is proportional when we have Rayleigh scattering. This is the only equation that may bother you, to 1 over lambda to the 4th, and lambda is the wavelength of light. And I will not bother you to tell you what the wavelength of light is. That may confuse you. But I will tell you that blue light has a wavelength which is about 1.5 times lower than red light. And so if you take 1.5 to the power 4, 1.5 to the power 4, you get 5. And that means in Rayleigh scattering, blue light has a 5 times higher probability to scatter than red light. And I'm going to demonstrate that to you in 2 complete different ways. The first way that I'm going to do that is to make it completely dark in the lecture hall and have light going straight up here. Then I will light a cigarette, and the smoke of a cigarette has particles that are smaller than 1/10 of a micron. And so the light that you will see that is scattered off the smoke will be blue. So you have seen in front of your own eyes Rayleigh scattering, because the red light more or less goes through. It is really the blue that dominates it, that has the highest probability. So we're first going to do that demonstration to show you Rayleigh scattering of cigarette smoke. And then I have a surprise for you to also show you me scattering. But let's first do the Rayleigh scattering with cigarette smoke. This is also not a pleasant demonstration. For those of you who think that lecturing is easy, no. Okay? Going to make it completely dark, and then I'm going to hold it in there. All lights off, all off, all off. So, we all agree that this is white light which is coming up. And you don't see the light here because there is nothing that scatters it in your direction. So you don't see light here, but now look. Those of you who see blue say, yeah. Those of you who do not see blue say no. You better see an eye doctor. Now comes the hardest part. If I inhale the smoke and I leave it in my lungs for a minute, there is water vapor in my lungs, and this water vapor will precipitate onto these very small smoke particles. And so the smoke particles will grow they will become small water drops, larger than 0.5 microns. And that means, if I hold it 1 minute in my lungs and puff it out, you will not see blue light, but you will see white light, because you're now in the me-scattering domain. All colors scattered equally. I will tell you that just before I puff it out, and you will see the white smoke, I will, just before I do that, I will remind you of the color that you see now. I will only do that for a few seconds, then I will remove it and I will empty my lungs. Terrible demo. Who saw the white light, just say yes. Yes. If any one of you has the courage to say no, who did not see white light? Thank you.